Hello everyone. We have assembled here for the inaugural session of the Dr. Mangala Naralikar Memorial Lecture Series that Pratishthan is going to organize in next few months. So this is first session. As all of you know, Dr. Mangala Naralikar passed away on 17th July 2023. She was a very well-known figure not only in the field of mathematics but even outside for the public at large because of her work at various levels in mathematics. She taught advanced mathematics in university department and she also taught to undergraduate classes, but her major contribution was in writing textbooks in Bal Bharati for school students. So she worked at all levels in mathematics. She was trustee, governing body member of Bhaskaracharya Pratishthan. So in a way we are paying a tribute to her memory through this lecture series. Her sister Mangala Bhopatkar approached us with a proposal that some activity should be run in the memory of Dr. Mrs. Naralikar, and then after discussion with her and our colleagues we decided to have this lecture series. Her sister, this Urmila Ganu, has decided to sponsor and she has funded this particular activity. So Bhaskaracharya Pratishthan is grateful to Mrs. Ganu as well as Mrs. Bhopatkar for this help for organizing in this. Today, the first session will be by Professor S.A. Katre, who is custodian of Bhaskaracharya Pratishthan and who was professor of mathematics at Savitribai Phule Pune University. He was also holding Lokmanya Tilak chair, the Department of Mathematics of Savitribai Phule Pune University. Today he will speak on how to find square root of a number. Okay. Professor Katre.
Welcome to the students, teachers and parents. I am giving this first lecture in the Dr. Mangala Naralikar Memorial Lecture Series as a tribute to Dr. Mangala Naralikar, who was the trustee of the Bhaskaracharya Pratishthan. My topic today is how to find the square root of a number. I have chosen this topic because Naralikar madam was keenly interested in high school mathematics and she gave a number of lectures, wrote books and also edited books published by Bal Bharati. So here we take the square root of a number. Number means what? That is first thing. We can have an integer, positive integer. It can be a rational number or it can be a real number. So we usually have a perfect square in mind when you want to find the square root. The ancient Indian mathematicians have discussed many operations for numbers. So addition, subtraction, these are inverse operations, multiplication and division. So a plus b, a minus b, a into b, a upon b. And then they also considered square of a number and square root of a number. So addition, multiplication and subtraction and division, they are operating on actually two numbers, right? But square of a single number you consider and square root of a single number. So square root and square, they are operations on a single number, okay? And you know the meaning of a square. So what is 2 square? 2 square is 4. What is 12 square? 144, very good. What is the square of 65?
3025. That's right, 4220.
So how do you do this quickly?
6 times the next consecutive.
Correct, very true. So 6 multiplied by 7, next number. So you consider this number 6 and 6 into 7, that is 42, and then you write 25 at the end. So, this simple procedure is there when the number is ending with 5, right, 65 ending with 5. You can find the square in this simple way, that 6 into 7 is 42 and then 25 after that. So, similarly, if I have a number like 105,
11025.
so 10 into 11 I consider 110 and then 25. Okay. So, 10 into next number 11, that is 110, and write 25 after that. But if I have a number like 29, I want to find the square of this. Anybody knows a method, good method to find out the square of a 2-digit number of this type? You have this.
We multiply the we find the square of the ones digit, write the unit digit of the answer, and then we take the tens digit as carryover, multiply the tens and one digit and multiply it by 2 plus the carryover, and we write the unit digit. The remaining is the carryover and the tens digit square plus the carryover and then.
Okay, so one can of course consider this such a 2-digit number, multiply this number by itself and find out the square. A method which is slightly simpler than this is the following, that 9, its square you just write down 81, okay, 9 square. Then 2 square you consider, you write it 04, okay. Now, so 0481 I have written. Now multiply these two, 9 into 2, that is 18, 18 into 2, 36, that you write here, okay. So what we have done, square of 981, square of 2, 04, and then 9 into 2 multiplied by 2. So 36 that I have written, then we can just add here. 841 is the square, okay. But if I have a number like this, say 82, then I will write square of 2, what is that, 4?
04.
So that is the thing, I must write 04. Please note that if you get single digit square, then also you write 2 digits there. So 04, and then 8 into 8 is 64, and then 8 into 2 multiplied by 2, 32, and then you add, okay. So 6724 is the square of 82. Is the method clear to everybody? That's now same method you can use for a number like this, 102 square if I want. Then I can write 04 and 100, and then 10 multiplied by 2, 20, 20 multiplied by 2 is 40, okay, and then 04401. If I have a 4-digit number, what we will do? So I will take a simple 4-digit number and I want to find the square of this. Okay. Now of course I can do like this, I can just separate this out, square of this, square of this. This is a 3-digit number and its square I have to find out. Again that I have to find separately, is a possibility, and then same method will work. But same method but slight modification I can do like this, and I can write now 12 square I can consider 144, but can you suggest something? I must in this case consider it as a 4-digit number, just as earlier we consider it 2-digit number, right, when you take a square, you remember. Similarly, I must consider it as a 4-digit number and then consider this square of this, then 12 multiplied by 20, so that is 12 multiplied by 20,
240.
240 multiplied by 2, so 480. Now, where I should write 480? So, I should not write anything here, I should write here. Okay. So, 480. Then I add so you can think of why this modification I have done. Basic idea in this in these both these methods is a plus b square is equal to, you know this formula, a square plus b square plus 2ab. So, and this is what is used actually in that method and this method, because in that when you have 2 digit number and its square, you are considering this as 20 plus 9 bracket square, and here you are using it as 2000 plus 12 bracket square, 2000 plus 12 bracket square, and if I use this formula, you will see that these are the steps you can mentally do it this way, provided the numbers are small. I have taken small numbers so that I know the square of this, I know the square of this, and multiplication is easy. But if you know the squares of 2 digit numbers, then using that you can always do the square of a 4 digit number. Okay. So, square of a 2 digit number, 3 digit number, 4 digit number, all these can be done in this way. So, there are of course other methods which we will not look at, but the inverse problem is to find the square root. Now, square root for any number you can find the square by multiplication, but to find the square root it should be a square, right, first of all, then we can think of its square root. So, what is the method of finding square root? For example, if you have already solved this problem 65 square and 4225, I have to find the square root of this number. Okay. Now, by our experience, we know that first of all the number of digits in the square root, what will that be? By looking at the given number, which is 4225, it is a 4 digit number. In the square root, how many digits will be there? 2 or 3. So, 2 digits is, of course, we know the answer. So, we know answer is 2 digit number, but there is a method to understand this. You have parts of 2 you make. Okay. How many parts of 2 digits are there? You look at that. So, 2 parts of 2 digits are there. In that case, the answer means square root will have 2 digits. So, square root, it has 2 digits. Okay. Square root has 2 digits. What are these 2 digits? You are given that it is a perfect square and the last 2 digits are 25. From that we get some clue. 5 is the last digit of the answer, right? So, this tells us that 5 is the last digit of my answer, because if the last digit of my number answer is 1, suppose, then square will be ending with 1. No, square I am saying. If my square root has 1 as the last digit, then its square will end with 1. Okay. 9 is, suppose my answer means square root has 9 at the end, then also the square will end with 1. That is what is happening, that. So, let us make a kind of table which is helpful to us. So, I will write here a number n or m and m square. Okay. So, ending with. So, if my number ends with 1, then m square will end with 1. If my number ends with 9, then also m square will end with 1, because 9 square is 81, right. If my number ends with 2, 4, correct, square will end with 4. and 8, 8 into 8 is 64. So, its square will also end with 4. Okay. Now, 3, 9, 7 also square is 9, 7 into 7 is 49. Then 4, 6 and 6 also 6, right. 6 square is what? 36. So, ending with 6, square is ending with 6. So, these two digits are there in the answer with square root, then the square is ending with 6, m square. What is remaining now? 5. 5, what is the answer? 5 and 0 ending with 0. So, I can guess kind of the last digit in the square root. If we know the last digit in the square, okay. But there is one difficulty in this. If my last digit in the square is 5, I will directly say square root will have 5 in the last digit. I am lucky. If the last digit in my number is 0, I can directly say 0 is the last digit in my answer. Answer means square root, right? That I can say. But if I am slightly unlucky, I will have suppose last digit in my square number is 1. Then what is the possibility of the square root? 1 or 9. Possible answer is either 1 or 9, and I have to choose which one is correct. Okay. So, at least this much we have understood that if we know the last digit of the given number, then we can at least get some idea of the last digit of the square root. Okay. Now, this is about last digit, but what about the first digit? First digit you have to get from the first two numbers. So, we have to decide whether the first digit is 1 or 2 or 3, etc. And the idea for that is, suppose I have 30 here, suppose 30, first two digits, and there is something here. This is 30, or let me look at the square root. So, in the square root I have got in this problem last digit is 5 as per this, and now suppose I have 35 here. Then 3, so 3 into 4, that would have been 12, and I would have 12 here. So, something is wrong here, I cannot take 3. This is one way of thinking, but once the last digit is known, can you think of a possible value of this first digit? So, if I take here 7, okay, suppose I take here 7, then this number is bigger than 70, right? And what is the square of this? That is 4900, 4900, right? If I have possible answer 7 here, and this is 75 is the possible answer, then 7 square will be there, 49, but this is 42 only. That means I must not take 7, I must take smaller number. Okay. So, 6 is a possibility. If I take say only 2 here, then when you take square of this 20 square is what? So, it is a very small number, right, 400. Then 30 square, 50 square. So, by some trial we arrive at 6 as the possible answer, right, 6, because 7 is not good. What about 5? No, that is also not. So, because 6 0 maximum thing which we get from 5 is 559, which is smaller than 60. 60 square is going to be 3600, okay, 3600, which is smaller. So, 6 is not, so we must, so 5 is not the possible answer. So, we must take 6 here. So, basic idea for finding out the first two digit is the following, that you find a square square of a digit which is less than or equal to 42, these first two digits. Okay. So, here you see 36 is less than equal to 42, and we must take the maximum square which is possible with this property, because 25 also 25 is less than equal to 42, but still a larger number I have 36, okay, and take largest such. Okay. So, 42 25 I get 36 less than equal to this. If I take 7 square, it crosses this. So, I do not take 7 square, okay. 7 I do not use that. So, my first digit is 6 and last means second is 5 after that. So, 65 is the answer. Okay. Now, I will take another, is this okay, that how to get the first digit. To get the first digit, I must look at the first two digits of the given number and find the largest square which can be subtracted from that, Largest such square in this case is 6 square, 7 square crosses it. So, I do not consider that. Okay. Now, let me take this number 9801, 9801, 99 square is the correct answer, but how you get it by this method? So, what is the number of digits in the square root? In the square root is equal to 2, because I have two parts here possible of 2 digits each. Okay, 2 parts of 2 digits each. Therefore, number of digits in the square root is equal to 2. Okay, that is the first observation. Now, what is the last digit? Because this is 1 here, we have seen 1 and 9 are the possible answers. So, let me write 1 here and 9 here. These are two possible answers, 1 and 9. So, let me write it here, because some of you have difficulty. So, 9801 is the given number. Because of this 1, I have possible answers ending with 1 and 9. Okay. Now, from this first two digits, what is the largest square which I can subtract from this?
9 square.
9 square. So, 8 square is 64, but I can still go to 9. Okay. 9 square is 81. So, my possible answers are 91 and 99. Which of these is the correct answer? 99. Why?
It's closer to 100 square.
Closer to that is fine, but I will give you a slightly better answer which is useful in other problems also. So, you know 95 square. 95 square is, this is a number between these two. What is the square of 95? It is 9025, we know that. Now, this number is larger than 95 square, so it must be the square of 99, correct? Because the number 95 is in between 91 and 99, and I am getting this number, it is larger than 95 square. That means, it must be the square of 99, not this. If it were smaller, then I would have given 91 as the answer. So, what about square root of 169, let us say, by the same method? 13 is the answer known to you, that is why I have taken this, but how you use the method, that is what I want to know. So, First of all, there are two parts. This is only one digit, these are two digits. Answer is having two digits. Yes.
This one we can have 3 or 7.
So, the possible answer is here 3 or 7, right? Because 9 it comes from 3 or 7. What is the first digit? Now from this 1, because what is the largest square which you can subtract from 1? That is 1 itself, 1 square is 1. So, I can have either this or this, these are two possible answers. Okay? These are two possible answers. Which one I should choose? For that I will try 15 square. What is 15 square? 225, because 1 into 2 you write, that is 2, and 25 after that, because we know that if the number ends with 5 then it is easy to find the square of that number. So, 225. Now, this number in this case is smaller than 15 and this is to be considered. Why? Because the given number is smaller than 225. Okay? Given number is smaller than 225. So, this is the correct answer. 13 is the correct answer. Is it okay? So, this is the method when you have a 4-digit number or a 3-digit number like this. Now, Aryabhatta actually has given a method to find the square root, which we will see now. And this method of Aryabhatta. Aryabhatta was a mathematician who wrote a book, Aryabhatiya, in 499 AD. Okay? In the 5th century, he wrote the book Aryabhatiya. And in the book Aryabhatiya, Aryabhatta has given a method to find out a square root of any perfect square. It can be 2-digit, 3-digit, 4-digit, and so on. What is the method of Aryabhatta? So, let us do it by taking a specific example. So, take any number, 2-digit number to start with. So, let me take, let us say 47. What is the square of 47? We know now how to find out the square. So, 49 I will write here, 16 here, then 7 into 4 is 28 and multiplied by 2, 56, add 9, 0, then 12 and 2, 2209. 2209 is the square of 47. Just take, it's okay, 49. Everybody understood this method, no? 7 square is 49, 4 square is 16, then 7 into 4 is 28, multiplied by 256, you write here, don't write here. Okay? This is kept. Then 9, 0, 2 and okay. Now, we should let us find the square root of 2209 by the method of Aryabhatta. So, 2209, we know the number of digits in the answer. Number of digits in the answer is 2. Okay. So, there will be 2 digits, we should get them. We are not using the method of this last digit, okay, because if I have larger number, then there can be many digits, 3 digits, 4 digits in the answer it can be. So, only for 2-digit numbers this method of looking at last digit is useful. So, we are not doing it that way, but initially I must find out the largest digit square. Okay. So, 4 square. So, I will take a equal to 4. Now, I am taking a equal to 4 to remind you a plus b square is equal to a square plus 2ab plus b square. Okay. So, I am taking a equal to 4. Now, I will subtract a square from these 2 digits. A square is what? 4, 4 square, 4 into 4, 4 into 4 is 16. I subtract it. what do you get? 6. After this, I take the next digit, I get 0 there. Okay. Now, a square is written here. This is a square. Now, what is 2 times a? 8. I will subtract 2ab from this number. What is b? That b is to be found out. What? Say 8 into what? 8 into 1 is 8, we can subtract. 8 into 5 also 40, we can subtract. 8 into 6, 48, we can subtract. 8 into 7, I can subtract. 2ab is equal to, suppose 8 into 8, if I take 8 into 8 is 64, I cannot subtract, but I can subtract 8 into 7. Okay. I want to subtract 2ab now, remember this 2ab. So, 56, what is the remainder? 4. So far I have taken these 2 digits, I have taken this digit also just now. Now take this digit 9. Okay. After taking the next digit, I will now subtract b square. So far what I have subtracted? A square I have subtracted first, then 2ab I have subtracted, and now I will subtract b square. What is b square? B is, this is b, right? B is equal to 7, okay, because I have taken b in such a way that I can subtract 2ab. Now subtract 7 square is what? 49, and I get 0. I get 0 means I am successful. I am getting full marks, not 0. B square equal to 49. And this is a perfect square. The given number is a perfect square. And the square root is 47. So, I have taken a equal to 4, that I could write here, and b is equal to 7, that I could write here. This is my answer, 47. A and b I am getting successively. A and b I am getting successively, and actually you might have understood that from my given number I am slowly subtracting a square, 2ab and b square, and I am getting 0 after that, and therefore my number is equal to a plus b bracket square, and a plus b is a square root. But there is slight care one has to take. This a is a digit actually, a is a digit, but the value of the digit depends upon the place where you keep that digit, isn't it? Value of the digit. For example, in 47, the value of this 7 is 7 itself, but this 4, because it is kept in the second place, this is tens place, right? The value of this 4 is actually 40, 4 into 10, right? This is 40 plus 7, 47. It is like that. So, this we, although we write a equal to say 4, this 4 is actually 40 because of the place where that a is kept. This a is actually 40, but for calculation purposes we can take it as a digit only. So, because we are taking it as a digit, our calculations are simple, we do not have to think of large numbers. Okay. Now, is the method clear to you? Let me explain the method again, that my number is 2209. I had 2 parts of this 22 and 09 of 2 digits each. From this part I should subtract a square maximum possible. Then I subtract from that 2ab. So, I find b. I first find a such that a square can be subtracted. Then I find b such that 2ab can be subtracted. And then I further subtract b square. Now, after subtracting all these things I get 0, and that means my number is the square of this a plus b, but this is slightly confusing because the a is a digit, b is a digit. Actually we are writing a after a we write b, because of that a is actually 10 times a. Okay. So, this is very effectively used by Aryabhata, and you can find the square root in this way. Now, the advantage of this is that the method that I had told earlier, that you find 25 square and see whether say 21 and 29, we have which one is correct, all that is not required. You are systematically going towards the answer. Now, there is a defect also in the previous method of finding square roots of 4-digit numbers. Suppose I give you 215 and ask you to find the square root by the previous method. Okay. Previous method is what? Look at the last digit. Last digit is 5. So, what is the square root? Here I should write 5, right. Now, here what is the first digit? It should be 1. Okay. So, what is the square root of 215? 15. Correct or not? No, you do not agree with me. Okay. So, do you find a mistake in this calculation? This method is correct only if the given number is a perfect square, right. Only if the given number is a perfect square, then this method will work. So, this method will not work correctly in this case. Here this number 215 is not a perfect square, and so if you use that method and find the square root, that answer is going to be not correct, it is wrong answer. However, it so happens that the method of Aryabhatta can give you approximate answer. Sometimes a number is not a perfect square, then it will have approximate square root, approximate square root. So, this approximate square root can be correct to 1 place of decimal, 2 places of decimal, like that. So, we shall take an example of this type. So, I want to find out the square root of 2. I want to find the square root of 2. Is 2 a perfect square? It is not a perfect square. I can find out an approximate square root of 2. Okay. Such an approximate square root of 2 was given earlier by Bodhayana, and Bodhayana was there around. So, Bodhayana 800 around this time BCE, 800 BCE, around this time Bodhayana was there, and he gave an approximate square root of 2, and that answer is 1 plus 1 upon 3 plus 1 upon, interesting, 3 into 4 minus 1 upon 3 into 4 into 34. This is an interesting answer given by Bodhayana, and people wonder how he had this answer, how he got this answer, and people are guessing what may be the method of Bodhayana, because Bodhayana gives you this answer only. He does not tell you how he has obtained this. So, today if possible we will see how he got it. Now, the method of Aryabhatta can be used, but before that tell me one thing. You know that the square root of 225 is what? Is 15, that is correct. Now, I will give you a number which is not an integer, okay, and you should tell me the square root of that. So, my number is 2.25. Can you tell me the square root of this number? 1.5 is correct answer. So, it is 1.5. Okay. So, this is also a square 2.25, it is not a whole number or not a natural number, but it is also a perfect square, it is the square of this number 1.5, and if you know the square root of this number, I can get the square root of this number also. Okay. So, because 1.5 square is exactly 2.25, and now there is one number here after the decimal point, and there are two numbers here 25. So, that is how you can get, if I want for example the square root of 0 to 25, then this is the number 225, its square root you should write down 15, square root of this is equal to, now there are 4 numbers digits after the decimal point, I should write 2. Do you agree with this? I should write 2. In this case, there are 2 digits, I have written one digit only after the decimal point. If there are 4 digits and this is a perfect square, then I can write the square root using 2 digits after the decimal point. Okay. So, this is a kind of understanding of if the number is not an integer, but it is a perfect square, then how to find the square root. So, you can use the method of Aryabhatta and go on finding the digits, and after the decimal point also you can get the digits to your requirement. So, you may want the answer correct to one place of decimal or 2 places of decimal. So, approximate square root you can find. So, let us try to find the square root of 2. Okay. Now, first of all, I will take a equal to 1 and 1 square I can subtract, a square equal to 1. 1 square I subtract and I get 1 as the remainder, 2 minus 1 is 1. Now, there is a decimal point here, I have not got 0. So, I have to go ahead actually, this is 2 is not a square. I have to go ahead, I have to get more digits. These digits will be taken after the decimal point. These digits will be taken after the decimal point, and at a time we take 2 digits 0 and 0. These 2 digits 0 and 0 will help me in finding out one more digit in the answer, one more digit in the answer after the decimal point. So, at present my answer is starting with 1, this is a equal to 1 I have considered, and I am writing 1 in the answer is square root. Now, by the method of Aryabhatta I should take 0. Okay. Aryabhatta goes on taking digits. So, this 0 I am taking, I should subtract what from this? 2ab. What is 2a? 2a is equal to 2. What is b? 2 into 5, right. So, let me try 2 into b equal to 5. Now, do not write anything, I will only explain. B equal to 5, 2 into 5 is 10. I subtract this, I get 0, then next number is 0. Okay. Next number I have taken from this 0. Now, what I should subtract from this? I should subtract, so I should subtract from this. So, 2ab, remember a square plus 2ab plus b square. So, this and this I have subtracted, I should subtract b square. What is b square? B is 5, 5 square is 25, I should subtract 25 from this. Can I subtract? No, I cannot subtract, I get a negative remainder in that case if I subtract. So, what I should do? I have to go back, retreat, I am getting some wrong answer. So, I go back. Go back means I should choose a proper value of b, so that I can not only subtract 2ab, but later I should also subtract b square. Okay. Such a b I should find. So, I had told you only find b such that 2ab can be subtracted. Yeah, 4 is the correct answer, but not only 2ab, I should also subtract b square. That is the actual logic. So, I will take b equal to not 5 but 4, but I hope you understood the reason why I am taking 4 and not 5. Okay. So, now I should subtract 8 from this, I get 2, and then I take 0. Next, so now, okay, now 4 square is equal to what? 16. That is b square. B square equal to 4 square equal to 16. 4. Now, 4 is the remainder. If the remainder is 0, suppose, then this would be actually square of 1.4. Okay. But remainder is not coming 0 here, remainder is 4. So, I can say that I have got the answer up to one place after the decimal point, okay, one digit. If I want to get better approximation, see, is this a good approximation? What is the square of 1.4? Square of 1.4 you can find out. 1.1, let us find out 16, 1, huh? Correct, 1.96, so 1 and 8, so 196, so 1.96 is the answer, 1.96. See that 1.4 is approximate square root of 2. Why? Because square of this is 1.96. Is it close to 2? Yes, right, it is close to 2. So, this is my answer correct to one place of decimal, which I have obtained by the method of Aryabhata. Okay. But suppose I want a slightly better answer, in which second digit is also there, because anyway this is not a perfect square. So, I should get approximate answer. I want to get one more digit, how should I proceed? To proceed to get the second digit here, I must take two more digits. Remember, for getting one additional digit, I must have two digits in my square. Okay. I have not changed by number, right, I have only put 0 0 here. Now, you proceed like this, and now I can take the number 0, and now you should remember what is to be done after this. This is slightly new to you, that I have got this answer here 1 4, okay. So far that is your A, just as your A was 1 and that was here answer. In the answer that A was there. Now, in the answer the number 14 is there. Okay. I should choose A as 14 and 2 times 14. So, A equal to 14, new A is coming from the answer. What is 2A? 2A is 28. And what is B now? 2AB I should subtract from this. I should subtract 2AB, B must be equal to 1, okay. 28 into 1 is 28, which I can subtract. But if I take B equal to 2, 28 into 2 is 56. Can I subtract 56 from this? I cannot. That means I must take B equal to 1 only, okay. Next digit here is 1, okay. And now you can proceed. So, B equal to 1. Every time I am getting new B and B. So, B equal to 1, subtract 28, I get 12. So, let me write down this 12 here, this remainder. From that I will take 0 from this and subtract B square is 1, that I will subtract, and I get 119. Okay. So, I completed this step, I have got the answer 1.41, which is a better square root of 2. Okay. It is closer to, means its square is closer to 2. Okay. If I want additional digits, what I should do? Again write 0 0 here and proceed by the same method. Every time I have to find out new B. Okay. There are 2 zeros, for 2AB for this, B square for this. Okay. Subtract. Next two digits 0 0, suppose I want. Then find B such that A means whatever you have obtained here, that is A. Whatever you have obtained so far, that is A. Find B such that 2AB can be subtracted when you put the next 0, and B square can be subtracted when you take the following 0. Is the method clear? I can go by the same procedure. Every time you should subtract 2AB and B square. Initially I subtract A square. Please note here that initially we subtracted A square, right. After that we are not finding A, etc. A is already there. Only we take 2 digits and subtract 2AB and B square. Again, then the new A is the whole answer. New A is the whole answer. I don't have to find A. Okay. A is the answer. And then find B such that 2AB can be subtracted when you put next 0, and for the next 0 I am subtracting B square. Okay. So, A is every time obtained in the answer, please note that. Only initially I find A. Initially, after that you do not have to find A. A is the answer. Is it okay? This is the method. of Aryabhata, and you can try, it is good to take a number, find its square, and to practice you should try to find the square root of that number and see whether your the original number you get or not. Okay. Take any number and take its square. So, this is how you should proceed. You can take for example, a number like 115, the square of this will be 13225. Okay. Okay. 11 into 12 is 132 and then 25. How many digits in the square root will be there? 3 digits will be there. First digit will be 1 square can be subtracted from this. So, it will start with 1. Then you find out b is equal to 1, okay, by considering next 2 digits, and finally, you will find again new b is equal to 5. Okay. So, this process you have to continue and you will get 115 as the answer. So, this is the procedure. Now, there is another interesting method which I will tell you now at the end of this talk. The interesting method which is there to find out the approximate square root is the following. So, this I will call as average reciprocal method. So, this is useful in finding approximate square root. Whenever the number is not a perfect square, you can find approximate square root by this method. The method is the following. I want to find square root of 2. Okay. So, to find this. So, first of all, you can take a approximate square root of 2, whichever is convenient to you, you take. Okay. So, 1 is a number which is also approximate square root of 2, 1 square is 1, which is somewhat close to 2, you can take that. I will suggest, because we do not have much time, I will take approximate square root m is equal to 4 by 3. Okay. Why? Because what is square of 4 by 3? 16 upon, so m square is 16 upon 9, right. And what is root 2 square? 2. 2 is, we can say 18 upon 9, right, 18 upon 9. This is close to this. So, I can, instead of taking 1 as approximate square root, I am taking 4 by 3 as approximate square root. It is somewhat, it is a better answer, I would say, to start with. And then using this approximate square root, I am finding still better approximate square root. How do I find it? So, m is 1 approximate square root and I take the reciprocal of m 1 by m, okay, multiply this by 2. So, 2 upon m, 2 upon m. Now, this m I am taking to be 4 by 3, which is smaller than root 2. Do you agree with that? Its square is 16 by 9. Square of this is 16 by 9, right, 4 by 3. It is smaller than 2, because 2 is 18 upon 9. So, this is smaller than this. So, 4 by 3 is certainly less than root 2. Everybody agrees with this, because square of this is 16 by 9, square of this is 2, 2 means 18 by 9. So, this is certainly smaller than this. Now, if I take 2 upon m, what can you say about 2 upon m? Will it be smaller than root 2 or larger than root 2? Larger is correct answer, and this is less than 2 upon m, means 2 upon 4 by 3. Actually, what is happening is m and 2 upon m, their product is 2, right. M and 2 upon m, their product is 2. If one of the numbers is smaller, then other has to be larger, isn't it? If m is smaller than root 2, because m and 2 upon m, their product is 2. So, this is larger than root 2 and this is smaller than root 2. Their product is the square of this number, square of root 2. Okay. Anyway, now what we do, if I take the average 4 by 3 plus this is actually, if I simplify this, then you will get 3 by 2. Whatever it is, this number plus this number upon 2. What is this called? Mean or arithmetic mean of the two numbers, right? Average of the two numbers. So, that is why average reciprocal, I have used the reciprocal of this number. Average, take the average. Now, this is average is a number in between these two numbers, isn't it? Average is a number in between these two numbers. So, it is probably closer to root 2. Okay. So, I take root 2 approximately equal to this number, and now you can simplify this and you can tell me what you get here. So, it is 17 by 12, very good, correct. Root 2 is approximately equal to 17 by 12. This answer is slightly larger than root 2, always by this method. When you use this method, you get the answer which is slightly larger than root 2. You can check that square of this number is bigger than 2. So, by the average reciprocal method, you always get a new approximation which is slightly larger than the square root. Now, this is a better approximation than the previous approximation. Previous approximation was what? 4 by 3. And from this I am getting 17 by 12. You can check that it is slightly better approximation than the previous one. If I use this and use the average reciprocal method, then I will get a still better approximation to root 2, means its square will be still closer to root 2. So, let me do it here. What I will do, 17 by 12, this is 1, another is 2 upon, this is m, suppose, this is m and this is 2 upon m. So, it is 17 by 12. Okay. Take the average, take the average. Do you see this 17 by 12 plus 2 upon 17 by 12 divided by 2. So, now you can tell me what you get. Just simplify this and tell me the numerator and denominator, and that is a still better answer, still better approximation to square root of 2. Okay. So, you have to do this calculation. This is for example 24 divided by 17 and then you have to divide by 2. So, I will give you the answer as 577 upon 408. Please check whether you get this answer, 577 upon 408. And now I would like you to calculate 1 plus 1 upon 3 plus 1 upon 3 into 4. This is actually 4 by 3, 4 by 3. What is this? 17 by 12. Just check whether it is 17 by 12. And then minus 1 upon 3 into 4 into 34. Now, you can find the common denominator 3, 4, 34 and simplify it. What is 3, 4, 34 product? It is 408. Just check. 408 is exactly 3 into 4 into 34. And what is the numerator? If you simplify this whole answer together. Yes? I will tell you, maybe you may be confused, this is 3 into 4 and this is 3 into 4 into 34. I am getting This is the number which I have written from the Bodhayana formula for root 2. Okay. It is this, that is what Bodhayana had written. And if you simplify this, denominator is 3 into 4 into 34, that is actually 408. And what is the numerator? By simplification, common denominator you have taken, right? 3 into 4 into 34 is the common denominator. So, here this will be 408, etc. Then this is 4 into 34. So, tell me the answer. You will see that it is exactly 577. 577 is the, when you simplify you will get 577 upon 408. So, what is the approximate value of root 2 obtained by Bodhayana? The approximate value which he wrote in this interesting form, it slowly comes in this way. First of all 4 by 3, then 17 by 12 which we obtained there, and if you go further you get additional term here, and the approximate value of root 2 is this, which is better than the previous approximate values. This approximate value of Bodhayana is correct to 5 places of decimal. Do you understand the meaning of this? Correct to 5 places of decimal. That means, if you write root 2 in the decimal form, it will be 1.41 etc. Okay. First 5 digits, if you get this way, they will be same in that. So, this is a very good approximate formula because it is correct to 5 places of decimal. And the method which Bodhayana used for this is now clear to you, that you take approximate square root of 2, take its reciprocal, but you multiply by that 2 upon that, take average, do it 2 times. In the same way, can you find now square root of 3? Square root of 3, if I want to find out, I should take approximate square root of 3 first of all, call it as m. M and 3 upon m take average.
1.7.
You can take some 1.5 square also you can take to start with, something you take, whatever is known to you, close to you, use that m, m plus 3 upon m average, use that again once more, you get still better approximate root. So, this is how the approximate square roots can be obtained by this average reciprocal method. So, I stop here with this, and if you have any questions, you are most welcome.
Sir, there is only one thing I want to point out for the others, how it fast converges.
Yes.
17 by 12 square is 289 upon 144, and 144 into 2 is 288. So the difference is just 1 upon 144 after the first step.
Is it clear? It is very close. 2 means what? Square of this 17 upon 12 square is equal to this. And what is 2? We can say 2 is 288 upon 144, right? This approximation is slightly larger. 17 by 12 is slightly larger than root 2. I mentioned that it is always slightly larger. How large? So, the measure is for the square difference is 1 upon 144. If you work more, you will still get a better approximation, you will see. Okay. So, you can take the square of this and see how that square of 577 upon 408 close to 2, you can check that. You will see that it is still better approximation. Okay. So, we stop here. Thank you.